Okay, it's discrete structures. We're doing functions. We're doing the homework problems for the section 1.5, which is about functions. So we're going to go through a lot of different functions in this homework problem. As always, with all homework problems, do the problems first, then check your answers with these answers. Okay? Okay, discrete structures, functions, these are the homework problems. Lots of homework problems, but they're all very simple. Okay, the first problem is so simple that I'm telling you it won't be on the test. I won't ask such a simple question on the test. It's too simple. So what we want is for different values of these things. So we want f of 1 is equal to 1 squared is 1 plus 3 is 4. G of 1 is 5 times 1 is 5 minus 11 is negative 6. F of 2 is 2 squared is 4 plus 3 is 7. G of 2 is 5 times 2 is 10 minus 11 is minus 1. F of 3 is 3 squared is 9 plus 3 is 12. G of 3 is 15 minus 11 is 4. F of 4 is 16. 4 times 4 is 16 plus 3 is 19. G of 4 is 5 times 4 is 20 minus 11 is 9. F of 5 is 25 plus 3 is 28. G of 5 is 55 is 25 minus 11. 25, 5 times 5 is 25 minus 11 is 14. Okay. To think about, is f of n plus g of n always an even number? Okay, so let's think about that. F of n plus g of n, well, that's always going to equal to n squared plus 3 plus 5n minus 11. Okay, well, by the way, let's just go through this. 4 plus minus 6 is minus 2. 7 plus minus 1 is 6. 12 plus 4 is 16, that's even. 19 plus 9 is 28, that's even. 28, so far so good, sounds good. Okay, so this is equal to n squared plus 5n, and that's going to be minus 8. Okay, can we factor that? That's n, and n is n squared. Minus 8, one's going to be plus, and one's going to be minus. So what do we have? 2 and 4 doesn't work. 8 and 1 doesn't work. Anyways, maybe that's not a good idea. Okay. Let's see, an even plus times an even. I don't see why it should be true, but okay, it just says to think about it. That question I won't ask on the test. Let's do number 2. Somebody put it in the comments the answer to that question. Number 2. Ready? Consider the function h goes from the positive numbers to the positive numbers. Okay, and now we have a cute definition. H of n is equal to the number of elements in the following set. K, member of n. Okay, such that k divides evenly into n. Okay? Okay? So it's the number of things, it's the number of numbers, it's the amount of numbers that go into n. Okay? Let's see. So let's plug in. H of 1, how many numbers go into 1? Just 1. H of 2, how many numbers go into 2? Well, 1, 2. Both of them go into 2, so this is 2. H of 3, how many numbers go into 3? Well, 1 and 3. That's it. It's a prime number, so there's 2 here. H of 4, how many numbers go into 4? 1, 2, and 4. So that's 3. H of 5, how many numbers go into 5? 2, 1 and 5. So write that 2. H of 6, that's a little bit more complicated. You ready? 1 goes into it, 2 goes into it, 3 goes into it, 6 goes into it. So that's 4. H of 7 is a prime number, so there's only 2. H of 8, let's go through it. 1, 2, 4, 8. Four numbers go into 8. H of 9, 1, 3, 9 goes into it, so that's 3 of them. And H of 10, let's see what that is. 1 goes into it, 2 goes into it, 5 goes into it, and 10 goes into it, so that's 4. Okay, and then it says, what about H of 73? Well, I'm not going to go through, but I know that 73 is a prime number, so that's 2. Okay, so that takes care of that. Number 3, now we go to languages. This was a nice problem. It's a nice definition. Let's go to problem number 3. Okay, let's do it. Number 3. Let sigma star, that's the set of all words, be the language using the letters A, B. Okay, so you have the alphabet is A, B. Okay. We already seen a useful function from sigma. We've already seen a useful function from sigma star to n. It is the length function, which already has a name called length. Calculate. Okay, so this is the stupid function. So we have a function, sigma star going to the natural numbers, and it's called length. Okay, just tells you how many letters there are in your string. So now they want you to calculate GTH what these things are. So BAB is equal to 3. You input a word, you get out a number. Okay, next. Okay, the next thing, I'm not going to write it out. 1, 2, 3, 4, 5, 6, 7, 8. Length of A is equal to 8. That's pretty silly. Okay, length of the empty word, that's a Greek lambda, is equal to 0. And then it says, okay, great. What is the image of length? And the answer is, well, these are all finite words. So what's the largest finite word you can have? It doesn't matter, because this is the natural numbers, the whole thing. So every single number here, as big as you are, you can find a word of that length. So this is not hard at all. Okay? Okay, we did 1, 2, and 3, now we're up to 5. 5, you look at this function. It's defined a certain way. It's an exercise 3. They give you the function. It's m comma n, take n, half of n, the floor of that, minus m minus 1, the floor of that. And they want you to calculate these values. So let's do it. Okay, so this is going to equal to 0 over 2, the floor, minus 1 over 2, the floor. Okay, so this is going to be 0 minus, minus 1 over 2 is negative a half. The floor of that is -1 minus -1. Okay, that's going to equal to 1, 0 minus -1/2 is equal to 1. So f of 0, 0 is 1. Let's do 8, 8. Okay, so this is going to be 8 over 2 floor, so that's going to be 4, minus 8 minus 1 is 7, so 7 over 2 floor. 7 over 2 is 3.5. The floor of 3.5 is 3, so 4 minus 3 is 1. Great, let's do the next one. Minus 8 over 2 floor minus, okay, hold on, minus 8 minus 1 is minus 9 over 2 floor. So this is equal to minus 8 over 2 is -4. The floor is -4. Minus, this is 9 over 2 is 4.5. -4.5. The floor of -4.5 is -5. So it's minus -5. So you get -4 plus 5, which is equal to 1. Okay, great. Okay, let's do 73. So this is 73 over 2. 73 we just saw is a prime number. 2 doesn't go into it. So it's 35, 36 is 70. 36 is 72. It's 36.5. Okay, minus 72 over 2. So that's the floor of that. So this is going to be 36 minus 36. Okay, and that's going to equal to 0. Okay, let's do negative 73. So this is going to be negative 73 over 2 floor minus, let's do this, negative 73 minus 1 is negative 74 over 2 floor. Okay, so let's do this. 73 over 2 is 36.5. So this is minus 36.5. So this is going to be minus 37. And this is going to be 74 is going to be 37, negative 37, negative 37. Sorry, let's do that again. 37 over 37 times 2 is 74. 60, 74. Okay, so it's going to be minus 37. So minus 37 minus 37 is plus 37 is equal to 0. Okay, main point is whenever we inputted an even or an odd, positive or negative, we got out a 1. I'm sorry, whenever we inputted an even, positive or negative, we got out a 1. Whenever we put in an odd number, positive or negative, we got out a 0. Okay? And the way to see this is as follows. If this is, let's see, so we're looking for f of m, m, or n, n, whatever, the same thing. So let's make this n, okay? So let's go through it. If this is even, then the floor is meaningless, okay? So it's just n over 2, okay? And n minus 1 is the one number lower than that. Okay, so n minus 1 is one number lower. So if this is even, this is going to be the odd number below it. The floor of that is going to be one number less than this. So you take n over 2 and you take one number minus one number less than that. That's going to equal to 1. As opposed to that, if n is odd, so then this is one number below. Okay. If n is odd, this is even, And so this is the same thing as the floor. So here you're going to go down one number, and here it's going to be exactly that number, one below, whatever, and then it's going to be 0. So basically, you have z cross z going to the set 0, 1, and basically this is the characteristic function of the even numbers. Again, when it's even, it outputs a 1. When it's odd, it outputs a 0. So that takes care of that. Okay. The interesting things is you're dealing not only with positive even numbers, but negative even numbers too. Okay, great. Next, number 8. Let's read the problem. S is equal to 1, 2, 3, 4, 5. Okay, and now it gives us 1, 2, 3, 4 functions. Okay, the functions are as follows. The identity on S, which goes from S to S. Okay, F, okay, so this is defined as 1 of S on little s is equal to S. That's that stupid function that outputs exactly what you input. Okay, F of N is also from S to S, and it's equal to 6 minus N. G of N is equal to max of 3, N. H of N is equal to max of 1, N minus 1. Okay? And now it wants us to do the following. Write each of these functions as a set of ordered pairs, i.e. list the elements in their graph, and then they want you to sketch a graph of each of these functions. So not only list them, but do them. Okay, so it's not hard because each one has inputs. There's only 5 inputs, so let's do it. You ready? If I input a 1, I output a 1. This is for 1. If I input a 2, I output a 2. If I input a 3, I output a 3. If I input a 4, I output a 4. If I input a 5, I output a 5. Great, let's do this one. Here, if I input a 1, 6 minus 1 is 5. If I input a 2, 6 minus 2 is 4. If I input a 3, 6 minus 3 is 3. If I input a 4, I output a 2. And if I input a 5, 6 minus 5 is I output a 1. Great, let's do this. If I input a 1, the max, hold on. This is max of 3, N. And this is min. Oh, I'm sorry, that's max of 1. So this is a max. Okay? Okay, so let's do this. This is also max. Ready? What's larger, 3 or 1? Answer 3. What's larger, 3 or 2? Answer 3. What's larger, 3 or 3? Answer 3. What's larger, 3 or 4? Answer 4. So if I put in 4, the output will be 4. What's larger, 3 or 5? If I put in 5, what's larger, 3 or 5? And the answer is 5. So if I put in 5, the output is 5. Okay, let's do this. If I put in 1, what's larger, 1 or n minus 1? 1 minus 1. So 1 or 0. So the answer is 1. That's larger. Great. If I put in 2, what's larger, 1 or 2 minus 1? And the answer is 2 minus 1 is 1. So what's larger? 1 or 2 minus 1? That's 1. Okay? Great. Next, what's larger? 1 or 2 or 3 minus 1? Answer 3 minus 1 is 2. Okay. What's larger? 4, I'm sorry, 1 or 4 minus 1? which is 3. What's larger, 1 or 5 minus 1, which is 4? So this is 5 comma 4. Okay, now they want us to graph these all. So I'm going to graph them, but I'm going to graph them with different colors. Okay, that's good. Ready? So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, now we're going to fill in all these things. Sounds good. Okay, great. Now, let's do lots of different colors here. So this, I need 4 colors. Hope we can do it. Ready? This is green. So this is going to be this. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. That's pretty simple. Next, let's do blue. This is blue. So what's the answer? 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 1, 5, 5, 1. So this is the first number, this is the second number. Okay, let's do this one. Okay, G. Okay, let's do this. So this is G. So, you ready? Well, maybe this should have gone the other way. Okay, anyways, 1, 3, 2, 3, 3, 3, 4, 4, 5, 5. Okay, and do we have another color here? Not really. Purple. We got purple. Okay, so this is purple. This is purple. So let's see. 1, 1, 2, 1, 3, 2, 4, 3, 5, 4. Okay, so we graphed it. Okay, not very interesting, but they asked us to do it, we do it. Ready? Let's do number 9. I'm not sure I graphed it right, but that's okay. Number 9. For n in z, so that's positive or negative numbers, f of n is equal to a half of minus 1 to the nth power plus 1. Now it says as follows. F is the characteristic function for some subset of z. Which subset? Okay, so the way to do this is what's called batting practice. You try a couple of different inputs. Try a couple of different inputs and see what values you get. Just try a few different things. So let's try it. So let's try f of 5. What do we get? Let's be careful. Minus 1 to the 5th power. So that's minus 1 times minus 1 times minus 1 times minus 1 times minus 1. Okay, you're going to have 5 of them. If you minus 1 times minus 1 is plus 1. Times another one, minus 1 is minus 1. Times another one is plus 1. Times another one is minus 1. So this is going to equal to a half times, this is at the end going to be minus 1 plus 1. Okay, minus 1 plus 1 is 0, times a half times 0 is 0. Very good. How about f of 6? Okay, that's going to equal to minus 1 times minus 1 to the 6th power. That's an even number, so that's going to be a half times minus 1 times minus 1 times 1, 6 times. That's going to be a 1 plus 1. That's going to be 1 plus 1 is 2. A half of 2 is 1. F of 77. Okay. The main point here is minus 1 to the 77. 77 is an odd number. Okay, so that's going to be a minus 1. Don't forget the plus 1. Okay, and that's going to be 0. 0 times a half is 0. 77 is odd. F of 78, 78 is equal to a half of 78. Minus 1 to the 78 is a 1 plus 1. That's going to equal to 2 to a half is 1. So basically, f is equal to the characteristic function of the even numbers, okay, which goes from z to the set. The only possible outputs over here is 0, 1. Okay? So we get that. Anyways, it all hinges on this minus 1 to an even number is 1, minus 1 to an odd number is minus 1. Okay? So that's number 9. Number 10. A and B are sets. Okay? And now you want to look at characteristic function of A times characteristic function on B. Now hold on. We know how to multiply numbers. We never learned how to multiply functions. That dot means multiply. So let me tell you what it means. It means sorry. Okay. Let me tell you what it is first of all, before I tell you what it means. It's a function also from some universe. These are both subsets of S. Subsets of S. So this is a function from S to the set 0, 1. Okay, now I got to tell you what it means. So chi of A times chi of B, okay, that gets an input a little s. Great. Now what's its value? Very simple. The value is chi of A at little s times chi of B at little s. Okay, this is multiplication. But multiplication of what? Multiplication, you usually think of 0 or 1, oh, that's just another way of saying true or false. Okay? But here, what I want you to do is think of 0 or 1 as the number 0 and the number 1. Those are two numbers. They're natural numbers, they're real numbers, call them whatever the hell you want. The point is, when you multiply them, you get another number. Okay, so great. Now, I asked the following. So, this is multiplication of numbers. Okay, this is a multiplication of functions. Question, what does this characterize? Okay, so great. So let's draw a picture. Here's your universe called S. There's a set called A. There's a set called B. Okay? And now I want to see, when does this function output a 1? Okay, so listen to what you have here. This could be a 0 or 1. This could be a 0 or 1. When is the output a 1? That's what we're trying to do. We're trying to characterize when is the output a 1. What things give you a 1? Well, the only way, if your possible outputs are 0 or 1, the only way you're possibly going to get a 1 is if this is a 1 and this is a 1. So if little s is an A, then this is a 1. If little s is a B, then this is a 1. If this is 1 and this is 1, then the output of the whole thing is 1. 1 times 1 is 1 times 1 is 1. So this is what it's going to characterize. The little s's in here are going to output a 1 over here, and they're going to output a 1 over here. As opposed to that, let's look at a little s over here. So here, this is going to output a 1, but here it's not in B. Therefore, it's going to be a 0. Chi sub B of this s is going to be 0. 1 times 0 is 0, so it's not going to highlight that. What about here? Well, here, this s, this is going to be a 1, but this is going to be a 0. 0 times 1 is 0, so it's not going to highlight that. Only here will it highlight it. What about here? Here, this is a 0 and this is a 0. 0 times 0 is 0. So what we say is the characteristic function of A times the characteristic function on B is equal to the characteristic function on A intersect B. That's exactly this middle region. Those things that are both in A and in B. Great. Let's do another problem. This is number 10. What about this? A plus B minus A intersect B. What is the characteristic function of A plus characteristic function of B minus characteristic function of A intersect B? Okay, so again we have to look at a picture. Here's a picture, here's S, here's A, here's B, and now we have to see what this means. So first of all, this whole thing is a function from S to 0, 1. Okay, but we never saw this before. We know how to add numbers. We don't know how to add functions. What does that mean? We don't know how to subtract functions. What does that mean? So what it means is as follows. The characteristic function of A plus the characteristic function on B minus the characteristic function of A intersect B at little s, that's an input from here, is equal to the characteristic function of A at little s plus the characteristic function of B at little s minus the characteristic function at A intersect B of little s. Just like before, we apply s to each one of the functions and we add them and subtract them. Okay, now we have to think about it again. We usually think as these two numbers, 0 and 1, as just telling you true or false. But they're not just telling you true or false. You can add them and you can subtract them. So let's go through it. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 2. Things like that. Okay, great. So now let's plug in 4 regions. Let's start with this region. Okay? You know what? We can do this with different colors. Let's do this. You ready? So, this is S. Question. What is this? Characteristic function of this little s, okay, plus characteristic function of B at little s minus characteristic function of A intersect B on little s. Let's see what it's equal to. That is 0 because it's not in A. That is 0 because it's not in B. That is 0 because it's not in here. So this is 0 plus 0 minus 0, which is equal to 0. So it's going to output a 0 here. Great. Let's do another color. Okay. How about this region? Okay. So let's do that. This is going to be characteristic function of A. We'll call this, I don't know, let's call this S also. S plus the characteristic function of B at little s minus the characteristic function of A intersect B at little s is equal to, let's see, it's in A, so that's going to equal to 1. it's not in, I'm sorry, it's not, that S is not in B, so that's going to equal to 0, so 1 plus 0. And it's not in here, so that's not going to be, that's going to be minus 0. So it's going to be 1 plus 0 minus 0, which is 1. So it will output a 1 here. Oh, that's good. Great. Let's do another color. What will the blue output? Okay, I'm not going to rewrite it, but basically, let's go through it. It's in here, so it's a 1. So it's going to be 1 plus, it's in there, so it's a 1. 1 second. It's in here too, so it's going to be a minus 1. Okay, what is 1 plus 1 minus 1? 1 plus 1 is 2 minus 1, so it's going to output a 1 over here. Okay, great. One more color. Oh, we have a purple someplace. Okay, anyways, let's do, there's purple. Okay, so what is this going to be? Let's see. So this is going to be, it's not in here, so it's going to be 0 plus, it's in B, so it's going to be a 1, and it's going to be minus this, it's not in there, so it's going to be a minus 0. So what is 0 plus 1 minus 0? That's equal to 1, so it's going to output a 1 here. Okay, so it's going to output a 0 here and a 1 in the other regions. So we can write this now as what? As the following. When does it output a 1? When does this function output a 1? Answer, it's the characteristic function of A union B. Okay, it's the union. This is, all this is going to output a 1. That's that. Great. Okay, one last function. You ready? This is part C of the class. I'm going to be a little bit quicker on this because it works out, it's almost the same as before. Okay, characteristic function of A plus characteristic function of B minus 2 times characteristic function of this. Okay, now you have to sit down and work out what it means. In here, it's going to output a 0. In here, it's going to output, it's in A, so it's a 1 minus 0, I'm sorry, plus 0 minus 2. No, it's going to be a 0 here too. So it's 1 plus 1, I'm sorry, 1 plus 0 minus 2 times 0, which is 1. Okay? Here, it's also going to output a 1. Here, it's going to output a 0. Okay, because you subtract twice of the middle thing. Okay, so this function is the characteristic function of A plus B. Those things in here or in here, but not in both. Okay. Great. Let's do 13, A and E. Okay, so 13a, f is a function, x to the third minus 4 to the x. F of x, this is 13a, equals x to the third minus 4x. And what they want you to calculate is f compose f. So f compose f of x is equal to f of x. Okay, let's do this with black so you can definitely see it. Okay, which is equal to f of x to the third minus 4x. Okay, which is equal to x to the third minus 4x to the third power minus 4 times x to the third minus 4x. Okay, Now, what they really want you to do is multiply this out, bring it together. I'm just not interested in doing it because that should be a pre-calculus thing. Okay, let's do the next one. F compose G compose H of X. Okay, so this is equal to F of G of H of X, 1, 2, 3. Okay, so first let's figure out what H of X is. H of X is X to the 4th. So this is equal to F of G of X to the 4th. Close parentheses. This is equal to, now we do what G is. What does G do? G does 1 over X squared plus 1. So this is F of 1 over X to the 4th squared plus 1. Okay, let's just refix that up. That's 1 over X to the 4th times X to the 4th is X to the 8th plus 1. Great. Now, what does F do? F does X to the 3rd minus 4X. So this is going to be what? This is going to be, you ready? 1 over X to the 3rd, X to the 8th plus 1 to the 3rd power minus 4 times 1 over X to the 8th plus 1. You might be able to fix this up. I'm not interested in it. This can go in, this can go in. Okay, anyways, that's enough. There are quick questions. Sometimes you have to simplify, sometimes you don't have to simplify. It depends which class you're dealing with. Anyways, I just wanted to show you what composition of function is. Great, so that's the end of the homework for section 1.5. Now we move on to section 1.6, which is sequences.